Good evening. Let's solve a question on SHM. A particle executes SHM on a straight line at two positions. Its velocities are u and v, while accelerations are alpha and beta respectively, where beta is greater than alpha and which is greater than 0. The distance between two positions is. So let's understand the situation by drawing a diagram. So let's say this is a straight line path on which this particle is performing SHM. This point is mean position x equal to 0. Now here it is given that alpha and beta are positive accelerations. Positive acceleration means your displacement should be negative. Okay. See, if accelerations are in this direction, then displacement should be negative. That means it should be on the left hand side. Now beta is greater than alpha. At beta, so beta is greater than alpha means beta is a higher acceleration, right? That means it is much more displaced than alpha. So let's say this is a location we are getting beta acceleration, and this is the location where we are getting alpha acceleration. And let's assume this is x1 displacement, this is x2 displacement. Okay. And accordingly, we can write down the velocities. At alpha acceleration, we are having u velocity. At beta acceleration, we are having v velocity. So, and we have been asked to calculate the distance between two positions. That means we have to calculate the mod of x2 minus x1. Okay, this we have to calculate. Now, as we are dealing with displacement, so here we can write down the equation of velocity in terms of displacement. That is u square equal to omega square a square minus x1 square, and v square equal to omega square a square minus x2 square. So let's solve these equations. So it will be u square by omega square, that is a square minus x1 square. Okay, so x1 square will be equal to a square minus u square by omega square. Similarly, x2 square will be equal to a square minus v square upon omega square. Okay, so we have to arrive at such kind of expression. So let's subtract the x2 square from the x1 square. So it will be x2 square minus x1 square, that will be equal to a square minus v square upon omega square minus a square minus u square upon omega square. Okay, so a square and a square will go away, and your expression will become u square upon omega square minus v square. Okay, so here we can write down another equation in terms of x1, x2 and alpha and beta. We know that acceleration is proportional to displacement, so we can write down alpha is equal to minus of omega square x1, whereas beta is equal to minus of omega square x2. So from here we can calculate the value of x1 as minus alpha upon omega square and x2 as minus beta upon omega square. Okay, so here you can just simplify x2 square minus x1 square bit. That will be x2 minus x1 into x1 plus x2 equal to u square minus v square upon omega square. So this will be x2 minus x1 equal to u square minus v square upon omega square 1 upon x1 plus x2. Okay, so from here we can calculate the value of x1 plus x2. That will be minus of alpha plus beta upon omega square, right? So we will substitute this value here. So it will be u square minus v square upon omega square, and so it will be minus alpha plus beta omega square. So this omega square and omega square will go away. It will be minus of u square minus v square upon alpha plus beta. Okay, now as we have to calculate this mod of x2 minus x1, and it is in the towards left, right? That means it is a negative displacement. So when we have to calculate the mod, then you will have to apply the additional negative sign, because we already know this is negative answer. So that is why mod of x2 minus x1, this will be equal to minus of this minus expression. So this will be u square minus v square upon alpha plus beta. So option number B, that is the correct solution for this question.